So let me walk you through the roadmap of how I'm going to solve this problem. Well, first we're going to set up and solve the airflow. So you'll see me choose the physics. We'll import a geometry sequence, and then we'll set what the materials are. In this case, it's air. We'll set the inlets and the outlets. For boundary conditions, we'll mesh it and solve it. Now, once that is done, we'll go on and add particle tracing, and then finally get some result statistics about that. And then I will go to my COMSOL screen. So what I'm looking at is basic COMSOL Multiphysics, and I'll say File, New. It says, oh, what do you want to do? Well, I want to do a 3D problem, so I'll hit Next. I'll close up this recently used, and then open up Fluid Flow. I'll go to single phase flow, and in this case I'll choose laminar. As I say, you probably in this case would want turbulent, but I'll get back to that. Go to Next, and I'm going to do a steady state solution, so I'll choose stationary and be done. Now the first thing it wants us to do is draw something. So I'm going to change, this is a 10 by 10, so it's most convenient to spec that in feet, so I'll set that to feet. And then I'm going to right click, and I can build stuff, or I can import it from a file. So guess what? I'm going to import it. So I'm going to choose this geometric sequence, and let's take a look at what we've done. Okay, so I'm going to build this one step at a time in front of you. So this sequence came in. We built this in COMSOL earlier by setting up work planes, drawing on it, etc. So let me build this one, and then zoom extents. And what you can see is in this first step, what I did is I created a work plane, and then I drew these rectangles, etc. And then on that work plane. Next, what we'll do is we'll choose extrude. Now I'll build that, and no surprise, we extrude it up. And now we've got the structure of the hallway and the office, but we don't have any door communicating between them. So let's fix that. So I go to another work plane. I'll build that. In fact, let me make this wireframe so we can see it. There we go. And so you can see that what I did is I drew on the work plane of the office wall, I drew a doorway. And then we'll extrude that, and then the doorway is present. Then finally, we're going to draw some windows. So let me show you that. Here are the windows, and then I'll build the whole thing. So now I have my complete geometry where I've got my hallway, I've got an office, I've got a communicating door that's wide open, and windows that are completely open. So next what we're going to do is set some materials. So I'll choose material. There's nothing defined right now, so I'll right-click on it, and I'll open the material browser. This opens a number of libraries that ship with COMSOL. I'll bring in the built-in one, open that up. That ships with base package of COMSOL Multiphysics. And here's air. I'll right-click on air and add it to the model, and it makes everything out of air now. Okay, so I've got a geometry, I've got a material. Let's look at my laminar flow. Okay, COMSOL's already set up laminar flow with fluid properties using the air. It's got no-slip walls everywhere and an initial value of no flow and no pressure. Well, that's fine as far as it goes. I need to spec some inlets and outlets. So let's go ahead and do that. I'll right-click on laminar flow. And then the middle things are boundary conditions, so I'll choose inlet. And I'll pick the hallway. Right-click to confirm that. And then I'll leave it as a velocity boundary condition and set that to a light breeze, in this case 0.15 meters per second. Now I need something for it to go out. So again, I'll right-click on laminar flow. I'll give it an outlet and then pick the end of the hallway and then the two open windows. So not that one, right-click to confirm. Not that one, not that one, right-click to confirm. And then I'll set it at pressure, no viscous stress, and I'm all set. Okay, now I actually, if you look, my wall conditions of no-slip wall now don't include those new conditions. I've got all my laminar flow all set up. Now, numerically, I need to mesh it, so I'll highlight mesh. In reality, I'd leave it as a normal mesh. But again, I want a fast answer really quick. So I'm gonna cheat. I'm gonna go down to extra coarse and build that. Now, this is really not a great mesh for this type of problem, but I'm looking to get a quick answer so you can see the process right here. So I've got this mesh. How many elements do we have in here? Oh, it's really small, 10,000 elements. It's an itty-bitty guy. Now, I'm going to do one more thing. I'm actually all set to solve. But again, in the effort to get it going really quick, if I right-click on the study, I can set up the solver and not have it run. So it's set it up, how it's going to solve this particular flow. And then what I'm going to do is go in and, again, just speed things up a bit. Rather than using an iterative solver, take a little bit longer, I'll right-click on direct and enable that. So now I've got the direct solver all set up to go. I also, from experience, know that this guy takes, wouldn't you know it, 26 Newton iterations, and we give it 25. So I'm just going to crank up that limit, let Newton have it a little bit longer, and then we're all set. All right, so the problem's all set. Let me right-click on Study and hit Compute, and away it goes. There we go. That's a little bit better. Okay, now first of all, it gave me a warning. What's it warning me about? Low minimum element quality. Okay, it's complaining about my mesh. Well, that's no surprise. I knew it was fairly lousy mesh. But I wanted a fast answer. So now let's go into velocity. This is a slice plot. Actually, I'm going to disable that. Where's disable? And let's get ourselves a slightly more appropriate plot here. We'll go into more plots, and then there's a multiple slice. There it is, multi-slice right there, and plot that. And now, as you can see, I've got airflow going in this open door. I've got air going down the hall, and I've got air going out the windows. So now the question is, where do the particles go?